Let's do some examples on this mole-to-mole ratio worksheet. The mole-to-mole ratio worksheet has a numerous balanced chemical equations here, where you've got, in this first one, potassium chlorate decomposing to produce potassium chloride and oxygen. The coefficient numbers 2, 2, and 3 tell us how many molecules of each type that you have. It also tells you how many moles of each type that you have. 2 moles of potassium chlorate, 2 moles of potassium chloride, 3 moles of oxygen, and it was also molecules. 2 molecules of potassium chlorate, 2 molecules of potassium chloride, and 3 molecules of oxygen. But what happens if we changed this number here, if we change the number of potassium chlorate to 4 instead of the 2? Well, if we have 4 potassium chlorate, okay, what would that do to the potassium chloride? Because we have this mole ratio, which is 2 potassium chlorate here, and there's 2 potassium chloride, okay, we can do this, set up a conversion factor here. We put the mole ratio between potassium chlorate and potassium chloride is 2 to 2. So you have 2 potassium chlorate for every 2 potassium chloride. Okay, now potassium chlorate was on the bottom here because it was on the top here. And if we multiply top times top, 4 times 2 gives us 8. Sorry about that. 8. And bottom times bottom, 1 times 2 is 2. That gives us 4. Okay, so there would be 4 potassium chloride. If this number here, if the potassium chlorates changed from 2 to 4, the potassium chloride would also change from 2 to 4. How much oxygen would we have if this number of potassium chloride changed from 2 to 4? How much oxygen would we have? Well, again, we're going to just do the math on this. I think you can see that there's a pretty easy way to do this. But let's just do the math. So if the potassium chlorate instead of 2 was 4, before 1, and our conversion is for every 2 potassium chlorate, and again I'm putting potassium chlorate on the bottom here because it was on the top here. Okay, so we've got, for every 2 potassium chlorate there are 3 oxygen, and this cancels out with this. We have top times top is 4 times 3 is 12, bottom times bottom, 1 times 2 is 2, and that would give us an answer of 6. Okay, so if this potassium chlorate changed from 2 to 4, the oxygen would change from 3 to 6, and you can see clearly what's going on here. This potassium chlorate doubled when it went from 2 to 4. This doubled. The oxygen also would have to double. It goes from 3 times 2 would be 6. And you can see the same thing that's going on here with these other ones. But let's just do the examples, okay? So if in this case now you still have the same mole ratio, 2 potassium chlorate, 2 potassium chloride, 3 oxygen. But if the oxygen, let me just erase these, kind of getting a little bit messy. If the oxygen changed, if this coefficient changed from 3 to 9, okay, we start off with 9 oxygen, okay. How many potassium chloride would we have? Well, the mole ratio between oxygen and potassium chloride is 3 to 2. 3 oxygen to 2 potassium chloride. Oxygen bottom here with top here cancel out. 9, top times top, 9 times 2 is 18. Bottom times bottom is 1 times 3 is 3. And then do the division. 18 divided by 3 is 6. And the same thing between the oxygen and the potassium chlorate. Okay. If we start out with 9 oxygen, the mole ratio between oxygen and potassium chlorate is 3 to 2. And again, the oxygen is on the bottom here because we start out with oxygen and we want to cancel that out. Oxygen. And it is a 3 to 2. We're going potassium chlorate here. Oxygen cancels out. Do the math. Top times top is 9 times 2 is 18. And 1 times 3 is 3. And we get 18 divided by 3 is 6. So take a look at what happened here. Oxygen, if we say we tripled it, it went from 3 to 9. Then everything would have to be tripled. Potassium chlorate would have to be tripled. 2 times 3 is 6. And the potassium chloride would also be tripled. 2 times 3 is 6. So our ratio there would be 6, 6, and 9. Let's take a look at one of them on the bottom here without really getting into it. Let's just take a look at one that maybe looks a little bit more difficult, but it's really not. Okay, we got this one here. We've got a mole ratio of 2 to 3, 2 lithium phosphate, 3 magnesium sulfate, 3 lithium sulfate, and 1 magnesium phosphate. That's the number of molecules and also the number of moles. 2 to 3 to 3 to 1 ratio. Okay, so on this, what would happen? Let's just go down to this one here, which is just looks a little more difficult, but it's really not. So our ratio 2 to 3 to 3 to 1 must always be maintained. But what happens if we went from 3 of the magnesium sulfate to 21 moles of magnesium sulfate? Well, here's what we start out with: 21 MgSO4. Okay, how many of the lithium phosphate would we have? Well, it's a 3 to 2 ratio. Okay, 3 to 2. We're going to put magnesium sulfate on the bottom because this is what we started out with, MgSO4. Okay, and it is a 3 to 2 ratio lithium phosphate. Do the math. 21 times 2 is 42. 1 times 3, bottom times bottom, is 3. Okay, 42 divided by 3. Well, what would that be? 42 divided by 3 is 14. Okay. What about the lithium sulfate? What about this one here? Okay, well, we can do that one as well. Okay, we're starting out, remember, we're starting out with 21 now instead of 3. So the mole ratio between magnesium sulfate, 3 MgSO4. Okay, and I'm just getting that number from right up here in our balanced equation for every 3 lithium sulfate. Okay, 21 times 3 is 63 divided by 3 gives us 21. And that makes sense because when you look at this, it's a 3 to 3 ratio. Okay, they're equal to each other, so 21 equals 21. All right. And let's do one more here. Sorry, I didn't mean to erase that. MgSO4 so if we start out with 21 now of magnesium sulfate, and this is an understood one here, right? It's not written, so we know it's understood one. And we go, our ratio is for every 3 magnesium sulfate, we have 1 magnesium phosphate. So we do our math. 21, top times top, 21 times 1 is 21. And again, these cancel out. 1 times 3, bottom times bottom is 3. 21 divided by 3 is 7. So that's what we would get. Now take a look at this. In the original problem, we had a mole ratio of 2 to 3 to 3 to 1. Okay? But our ratio of 2 to 3 to 3 to 1, if we changed this to 21, we had to multiply the 3 times 7 to get 21. All we're doing is we're doing the same thing to each one of these coefficients to get our numbers, right? So this had to be, if this, for the magnesium sulfate, had to be multiplied by 7 to get the 21, then this lithium phosphate also needs to be multiplied by 7 to get 14. And this needs to be multiplied by 7, and it gives us 21. And this needs to be multiplied by 7 to get 7. And that's where these numbers are coming from. So you can do the rest of them. I'm not going to even finish this one here. I think you guys can do this. And if you have any questions, please, please, please email your teachers and let's get this right. You can do this. Good luck.